Testing, testing. 1, 7, 4. Testing. Welcome to Calculus in the PM. I'm your host, Mr. Shandelka. In case you've just joined us, this is Calculus in the PM. I'm your host, Mr. Shandelka. Brought to you by AAA Acme Chimney Sweeping Service. Have you had your chimneys checked? Don't wait for winter. Specializing in coal and wood-burning chimneys. Coal, nature's fuel. It's totally organic. Don't panic. Just give me a call. I've made up my business cards, everything. Chimney sweeping. Told you. You see the Belfer you can see the chimneys there. They hired me on them. Like I said, this carbon tax thing is really doing a number on me, hey? I'm recording this. So I'll see how this winter goes. I'm trying to get rich.
Send a suggestion to Rose.
Yeah, throw out the internet. So, anyways, what's a logarithm? First thing we have to understand before I'm going to throw natural log derivatives at you. Now, we've seen this in September, but I'm not always convinced people remember things. People understand exponents pretty darn good, I hope. 2 cubed is 8. What's the inverse of an exponential type function? Logarithm. So, doing an exponent, the inverse operation is doing the log. When I say log base 2 of 8, and you didn't know what the answer is, what should you say in your head when you see log base 2 of 8? You say
2 to the power of what equals 8.
2 to the what equals 8. You think, yeah, 2 to the cube. This is the same information rearranged. If you have a log equation given, and it makes things easier, you should be able to go back and forth between these two things without even thinking about it. There's no division or anything like that involved, right? These are functions and they're inverse operations of each other. Okay. This isn't a function here. These are just little questions. So this means log base 5 of 1/25 means 5 to the Gives me 1 out of 25. 5 to the What is that in this case? You guys know how to evaluate this one?
-2.
Okay, you're right, -2. He knows. How does he know this? The log base 5 of, what's another way of writing? How do you think he got a -2 out of this? He's right.
No, I didn't think about it.
What's that?
I moved it down.
Okay, so maybe in your head you said, well, it's 1/5 squared. And then you said log base 5 of 5 to the -2. Is that maybe what you said? Then it's very easy. 5 to the what, because log base 5, gives me 5 to the -2. Well, that's super obvious then, right? If you can dream it up like this. 5 to the what gives me 5 to the -2. It's -2. That's what you're saying. Whether you wrote it out or thought it through like that. If you need to write it out like this, go ahead. If you can see it, I'm sure the thought processes are there. But you absolutely need to understand the ideas of logs. Now, when we're talking with e's, and we will be talking e squared, e to the 2x, etc. more often, you're going to get used to this kind of way of doing it, right? Like that. Thinking of it, 5 to the what, e to the what. Okay. Now, these are things you saw at the start of the year too. But just reminding you, log problems give you exponents. That's the answer to a log problem. It's whatever the exponent should be. This means the property of logs are really the same as the exponent properties. So, let's go through all these properties real quickly because, well, we need to know. So, on this side here, I've got my exponent rules, the corresponding log rule, right? So with products, now I don't want you to actually multiply these out because yes, you know this is 4, and you know this is 8, and it should be 32. But keeping the base the same. What is this rewritten as? 2 to the Oh my gosh. Yeah, 2 to the 5. You add the exponents when you take a product. Same base, though. If the bases aren't the same, you're hooped, right? You can't do anything further. You're not necessarily hooped. Hey, look at this. That's an exponent, would have underlined, plus another exponent. What are we talking about there? Well, let's just see here. So this is 4, 2 to the what? This is 2 plus 3 is 5, right? Hey, this is the same thing, but do you see what I'm trying to say is this is the same information here, right? Okay? And then, like you were saying, though, the other way of saying it is,
Same basis, so, and if it's an addition sign, you multiply the,
this is also equal, instead of evaluating it this way, if you can evaluate it that way, do it, it's quicker. But if you can't, and you've got to combine those two logs, adding exponents is the same as multiplying their products. So then you said the log of base 2 of 4 times 8. So in this case, we'll say 32, right? Okay. Hey, what's the log base 2 of 32? Check. This works, doesn't it? When you're adding logs, you're actually multiplying the innards, the insides, right? Okay, so then it shouldn't come as a surprise when we do this, right? Combine for 1, 2 to the negative 1. Now, it shouldn't be a surprise here. I basically gave the same expression here, so this is going to be log base 2 of 4. Okay, wait. Somebody said somebody's not sure what we're doing here? Or what? No? If I want to, does somebody need clarification? Okay. So when you see log base 2 of 4, you say 2 to the what makes 4? That's 2. Minus 8. 2 to the what makes 8? 3. I'm giving the same information here, right? Now this isn't what we're really after, but we're going to just see. If I was to rewrite these as one log, and you see subtraction, you think subtraction with exponents means quotients, division, right? So what are you going to rewrite this as? Log base 2 of 4 over 8, 1/2. Okay, that's good, right? Next, a power on a power. What do you do with the exponents in this case? Multiply 2 to the 6. Yeah, we're good on that. That's 64.
3 times log 2 to the 4, or 2x equals 4.
Okay, so we can see a few different ways. The log base 2 of 4 should be 2, right, times the 3, should be. You should come out with a 6 out of this. But, what do you guys remember here? We know that it should be 6, because I'm giving the same expression differently. What do you guys remember when you have a little exponent in front, or, yeah, I see the waving arms, yank her out in front. That's not like with your, it's not an exponent that you're doing a derivative with, but it's almost the same idea, right? You pull the exponent down. Okay. As long as this 4, like this 3 is on everything inside that. More about that later. So this could be rewritten as, oh, I'll change colors here, just so it's not mixed up with the other. 3 times, because the power of a power is multiplying, right? Which is, you guys see what we did? Pull the exponent down 3 times, well, log base 2 of 4 is 2, equals 6. Okay, just so my notes are complete, just me. Okay, give you guys a second here. Try these. Write these all as the log of a single thing, a single quantity. So they'll all come out to be log of. Pardon me. I'll give you guys some time. Do them. Do them all. Pause. Okay? We've had a chance with some of these. Now, to write this, by the way, if there's no base given, log of x, what do you assume the base is? Log, 10. If it's ln, assume it's natural log, e. Okay. These are all log base 10. It doesn't matter if it's log base 2 or 10 or 7 or e. Same rules. So, anything that's added is multiplied, so this is going to be the log of x, y, subtract the log z, so z on the bottom, subtract the w. Okay, that should look like that. If you want to put brackets around it, makes you feel good, do it. I would say rewrite this before you put everything inside the log first, because you're multiplying the 3 in front and the 2 in front. They become exponents. So I'll do 2 steps for this. You could do it in one, sure. So far, no calculus done. Then, they're added, so I'm going to put it in a bracket here. A cubed, b squared. Right? Watch it, I make mistakes, especially when I'm talking.
Does it have to be in brackets?
It becomes ambiguous if you don't, because how would I say the difference between the log of a cubed times b squared, not in there? How do I know the difference between this and this without brackets? That's why. If you don't see brackets, you typically can assume that it's only the first thing. And by space, it's ambiguous. And it's, yeah. So that's why I'm using bracket. Yes? No? Back to this. We got r with a half power on it, or square root, and s with the 4th power, right? I'm going to skip straight to it then. The log. You don't need this bracket because it is assumed that the whole rational portion here is in here, but I'll use either square root or r to the half. It doesn't matter. It means the same thing, s to the 4. Are we good with that? I believe you then. Now the calculus. All right. I'm going to give you guys a formula here. This natural log formula. Take a look, a loop. If you got the derivative of some log function, that u represents like 3x plus 2 or something inside, right? You just take whatever's inside the log and you say it's 1 over, right? Times the derivative of the inside. That's the chain rule, right? Now, we'll do the simplest one real quickly and then we'll get into these. The simplest one is, write this over here, if y equals the natural log of x. According to that formula, what is the derivative of the natural log of x? And if you have this memorized, the rest just works. Well, let's use this formula again. The derivative of the natural log of u. So in this case, u is x, right? So, is 1 over whatever you got inside the log, 1 over x. What's the derivative of the inside? The derivative of x in this case? 1. So this one doesn't have any leftover inside to do. If you memorize this, everything else works out just fine. But this is something you can't do from first principles, like with that x squared minus, take this, subtract the exponents. It doesn't work like that. It's like the cosine trig functions. You just got to know something. Pardon me. Soot from the chimney is just coming up. Yeah. No. Memorize this. And if you memorize this and you have something other than x inside here, right? You have something else inside here. It's still the same thing, 1 over the thing you got in there. But then you have to do the derivative of the inside, right? Chimney. So as long as you have that memorized, this part of it falls into place. Okay? Have to have that memorized. So let's go with this, A. So we've got y equals the natural log of 7x. So the derivative will be the automatic part is 1 over 7x. Exactly as is, don't change a thing. Right? Then do the derivative of the inside. 7. Now, these are simple, so simplify them. 7 over 7x is 1 over x, right? Once you do a few of these, you could simplify them in your head, probably. C, you should be able to do in a heartbeat.
0.
Why is it 0? Because it's a constant. Natural log of 10. There's no x, there's no variable there. Good. D. A couple of strategies for this one. Anyone? Should we just go for it?
Why don't we combine it?
Yeah, and then combine it together and do the derivative of that.
Combine it together. Oh, like x squared? That's a fool's way to do it.
Oh.
No, it really is.
You have a shot.
X squared minus 9, though. You could do that. No, you could do that. But then if I want it fully factored at the end, you're unfactoring it.
Yeah.
We're doing E, yeah. Okay, you're right, though. That's one strategy. I just saying, giving you the gears.
We're doing E. You wrote D.
Oh, I didn't have E circled?
You have E, so you have E. You wrote D.
Oh. Gotcha. Thank you. Thank you as much. So, yeah, what are you thinking?
And you just do the natural log of x minus 3 by itself and then multiply that by the natural log of x plus 3.
Not quite the way you said it, and maybe the way you're thinking of it is fine. But how about this? Well, do you want to try it as is then? Or do we, I think maybe what you're getting at, I don't know. And I think you might have been on the right idea. The easiest way is to say, well, x minus 3 plus, make it two simpler problems. Does that make sense? Now you can do the derivative. I don't know if that's what you're getting at. Didn't?
I just said multiply it.
Yeah, you did. So I wasn't sure if you're meaning because they're multiplied, can we separate them into, because you did say individuals. But anyways, the derivative of natural log of x minus 3, 1 over x minus 3. What's the derivative of the inside then?
1.
So it's just this. Taint it? Taint so? Then what? Can you combine those? Yep. Uh-oh. Yeah, you guys got to remember how to do these things. Common.
Yeah. Multiply each one by x
Yeah.
plus 3 and x minus 3 and
Then you combine, right? This is not a solving equation with 0 on one side, so you're not going to get rid of anything, right? So dy by dx is equal to, multiply top and bottom by a form of 1, really, right? X plus 3 over x plus 3. This one, x minus 3. That's really what I'm doing. If you could do it one step in your head, that's fine. So x plus 3 plus x minus 3. I'm only putting in brackets in case that was subtraction, you'd be hooped. And then the bottom is, don't multiply the bottom out ever unless you really see a need. Keep things factored if possible. So it's 2x on the top.
Do you care how we did that?
No.
Yeah.
No. You could have done, like you said, x squared minus 9, you would have had this
Yeah.
fully factored, and it actually would have been pretty quick too. Most times, though, you won't have a perfect difference of squares, and it won't be as easy. In this case, yeah, 2x over. Now, sometimes on questions, I'll say only show the first step, but don't manipulate. If you were to do it just like this, it still gives you the same answer. But without separating the natural log, like the adding part, you'd say, well, 1 over x minus 3, x plus 3. And then you do the chain rule to do the derivative of the inside afterwards, right? Okay, so there's 3 ways students have mentioned. To do these ones, though, how would you simplify before doing these? I don't want you to actually do the derivatives here, but just what is the kind of, what makes this easier? Yeah. What's the first thing you do? I kind of told you. Separate using the addition to multiplication rule, right? Hope you know. Then you could bring that 3 out if you want, and so on. You could. But this would be even pretty good to do it just this way. Actually. How about b? I guess y equals natural log. What would you do to this guy? Three halves outside. I think it would be even easier, yeah. And that's what I was mentioning over here. You could have done that too, right? You could have brought that 3 out as another step. But so 3. Yeah. Rewrite this again. Y equals 3 halves. Natural log of 2x plus 9. Right? Then what? How could you simplify with the next one? 3, and then subtract. You could distribute the 3 if you wish.
You don't have to.
Well, I'll just show it as a first step, and then you could choose if you wanted to. Natural log of x to the 4 minus natural log of x minus 2. I just didn't want to do 2 steps at once. I actually would put the 3 in front of each item. As long as you got this thinking process. Okay? You guys good on this one? Okay, that isn't calculus, that's just simplifying. Yeah?
So when you have a number outside the natural log, how do you use it?
So this you're talking about, or this?
Like, yeah.
B? If you were to actually do the calculus on it, you're saying?
Yeah.
Well, do B. Okay. That's a good question. So you got a number in front of anything, right? You just keep it there and you multiply it. So, just like if you had 2x cubed, the derivative is 2 times 3x squared, right? You just do it and you say it's 6. So here, I'm going to just keep it as 3 halves. That's the number. Then, the derivative, because of the natural log thing, is 1 over. Times, now we're doing the chain rule, the inside's derivative 2. And from there, you could simplify the 2's cancel top and bottom, and you just have 2x plus 9 on the denominator.
So you don't do the derivative like 3 over 2?
It's a constant. Just think of it this way. I know what you're saying, but if I was doing 3x to the 5, would you think of doing the derivative of 3, 0, times x, to the 5 plus, yeah. You just say, you'd actually jump straight into it and say 15, but you'd say 3 times, and then 5x to the 4, right? And you, like I say, you just jump right into it and say 15.
Okay.
But that's no different than this. But I know it's more complicated, but you got natural logs and fractions and stuff. That answers your mouse?
Yes.
Okay. So then what? Wondering here for today. Pardon me. Let's just see here, because I'm going to use another day anyways, but which ones can we do right now? Page 183. Now, I know you have some from the first part of part 1 of this stuff, eh? But number 11, oh, you can't do 11 yet. 13. Can't do 13 yet, 15 through, but you can do today. Yep, 17, 16. Those are good. 15, 16, 17, let's see about 20. 20 is a dandy. 21, gosh, I picked some. 21, yeah. No, you can't, I didn't show you that yet. 20. Those ones today, you see about, nope. 32, let's see here. But 32 is a doozy, I like it. You know what, I'm even going to scratch some of those others. There's too much emphasis on something now I've realized a year later. Oh, I like 53. We'll get 53 today. $59. Let me see what 60 then. Not 60, 59. Okay, from what we learned today, you should be able to do those questions. Okay? 32, 59, and then 15 through 17 and 20. Remember the evens, I've got answers right down there if you can read them. Are they on your printout too, the even answers?
Yeah.
Yeah, okay. I forgot if I included them.